Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering course. In today's video, we are going to discuss the moment analysis. Over the last video, we explained what is the force, as a force vector. We discussed how we can calculate the force resultant. Also, how we discuss how we can calculate the unknown forces, doing some static force analysis. Today, we are going to discuss the moment that would be produced because of a force. This is going to be the objective of today's lecture. So what is a moment? According to this expression, the moment is a force times the normal distance. I'm going to go over this expression with more detail, especially I'm going to explain what does it mean a normal distance and how we can specify or define this normal distance to a force to calculate a moment. So anyway, we are going to discuss this with more detail, but still the question is, what is the physical meaning of a moment? What does it mean a moment in general? You could deal with the moment like a kind of energy. It is like a special energy, a special form of the energy. For example, if we're going to talk about the work it is force times distance. It is energy. The heat, it is another form of the energy. So it means that the energy, it could be with any form. The work is energy. The spring, it has some kind of energy. The heat, it is another form of the energy. The moment, it is another form of the energy. We can deal with it like it is a potential or it is kind of energy, but it is a special form of the energy. This is one way. There are lots of useful things that we're gonna use the moment for. Moment, it is very helpful. One of the things, for example, the moment can give more potential to the force. So what does it mean to give more potential to the force? Just to explain, let us consider this simple example of a box. And assume that I ask you to carry this box, just to move it up. This is the box with a certain mass or a certain weight, whatever it is. And I'm asking you just to pull up this box with a certain force F. So you should apply enough force, and this force, it should be bigger than the weight of the box, so it will be moving up. Other than that, if this force, it is not bigger than the weight of this box will not be moving. You will not be able to raise or lift this box. But there is another way, for example, to make it easy. If you don't have enough force to lift this box, you can use a lever mechanism. This is the simplest mechanical mechanism that have been used in humanity. This is the simplest form of mechanics. So simply we can use a lever that you're gonna have a kind of pivot, and then you're gonna have like this, let's say like stick or bar or whatever, and this bar, it will be pivoted and fixed about this point. Then your objective is just to put the box on the top of this bar. Then if you try to apply some force here, this would be easily more simple and easy will be lifted. So it means that this force, which could be lower than or smaller than the weight of the box, or in case that this force is not big enough to lift this box, if you're gonna use a lever, with the same force, you can lift the box. It means that you are giving more potential to the force. You are giving more benefit to the force. So this is one of the things why we are using moment. So why the force? For example, in this case, there is no lifting. The force, if we're going to assume that we don't have here a weight of this box. So for this case, for example, the force, it is lower than the weight of the box, so there is no lifting for this case. But we're still using the same force. We are using the same force. But in this case, it had been lifted. It will be lifted. Why it will be lifted for this case, not that case? Despite we're still using the same force. Because the force, in this case, we are not applying a direct force over the box. Instead, we are applying indirect force. This indirect force, it will be in the form of a moment. We are applying kind of a moment that is gonna lift this box from underneath the box to be lifted up. So this kind of a moment, so we're applying a moment in this case. This moment gives more potential to the force, to give more energy for you to lift this box. So if you try to apply a direct force, so the difference between this case and that case is, the difference between these two cases is that here we are applying a direct force. But here we are applying the force, the same force, but it has indirect effect. This indirect effect, it will be in the form of a moment. This moment, it can be calculated using this expression as F times D, and we are going to discuss this expression with more detail. But here we're just discussing what is a moment. Make sense? So one of the useful things of the moment, that the force itself, if you use the force directly, you probably may not be able to use the force, or the force would be lower than the weight of the box, so it will not be effectively used. So to give more potential and more benefit for this force, it is better to use a lever mechanism. For example, this lever mechanism is going to give more potential to this force in the form of a moment. Gives more energy to the force to lift this box in the form of a moment. So it means that you're going to deal with the force. You're still using the same force, but you are using its indirect effect. So this is a direct effect of the force. This is the indirect of the effect of the force in the form of a moment. This is one of the useful things of the moment. Another benefit of the moment, that we could use it to give rotation to some of the mechanical components. For example, the difference between the force and the moment is what type of motion that the force could produce, what type of motion that the moment could produce. The force could give a translational motion, that it would move objects. But the force, if it is it has a direct effect, it will not give any rotation to the object. Like for example, if you do have a box, and this box is settled over the ground, sitting over the ground, and for some reason you would like to move this box, just move it, push it. So you are going to apply a moment or a force? No, definitely you should apply a force. So you're going to apply a force. The force, the tendency of this force is just to give push, movement, to move this box. Change the place of this box from one position to the other position under one condition, that this box will not be rotating. There is no rotation. So the force, it has a direct effect. The direct effect of any force, that it will has the tendency to move objects with no rotation. But the moment, it gives rotations to objects. For example, if you do have a wheel, assume that you do have a wheel, and this wheel is pivoted somewhere about any point, like assume that this is a wheel known as the flywheel or whatever. These are some arms, and this is going to be the rim of this wheel. Okay, so if I ask you to give rotation to the wheel, what you're gonna do? You're gonna use your both hands, and you're gonna start to rotate like the steering in the car. So you're gonna use your both hands to give rotation. This, it means that you are applying a moment. You are applying a moment. Despite the moment, it is related to the force, or it is originally generated from a force. But the force here, I'm not dealing with the direct effect with the force, but I'm considering the indirect effect of the force in the form of a moment. So the moment, it will give rotation. Because of a moment, if you apply a moment over this wheel, it will start to rotate. It will start to rotate. So generally speaking, the difference between the force and the moment is that the force, its direct effect, it will give push, it will give movement, it will move objects with no rotation. But the moment, it will give rotation to objects. So generally speaking, if we're gonna talk about the gears inside the transmission system of the car, these gears, what type of motion that these gears are doing? These gears are rotating inside the transmission system, inside the gearbox. It means that to give potential, to give energy and power to these gears to rotate, you should apply on them with a moment, not a force. Despite there should be a force, but we are not dealing with the force as much as we are dealing with the moment that is going to be produced from a force. So generally speaking, any mechanical component that is rotating under rotational motion, you should use a moment to give it a moment, to give it a rotation. So any object to rotate, it requires a moment. But any object to move with no rotation requires a force. Make sense? So this is another benefit, another use of the moment, that we are using the moment to give rotation to mechanical components who are rotating inside the transmission system of the vehicle or the machine or any mechanical application. Make sense? So this is some of the benefits, and there are a lot of things that we could use the moment for. But generally speaking, returning back again to this expression, what does it mean a moment in terms of according to this expression, the moment, it is a force times the normal distance. So what does it mean this? It means that the moment, generally speaking, it is very hard to find a very pure moment that can be created or generated by itself. What does it mean this? It means that to create a moment or to generate a moment over any object, you should apply a force. It means that the moment comes from a force. It cannot be created or generated by itself. It requires a force to create a moment. But this force, it should be multiplied by a distance. It should be displaced, especially located. And the indirect effect of this force will give you a moment. So generally speaking, the force, it has two effects. It will have a direct effect and indirect effect. The indirect effect of the force gives a moment, but under one condition, that there should be a moment at a point. And we are going to explain this according to this expression, that the moment, it will equal to the force times the normal distance. So what does it mean, a force times the normal distance, and how we can calculate the moment according to this expression? So again, the moment, it is very hard in reality, in life, to find a moment that is created by itself. In most of the cases, there should be a force behind creating this moment. This force, it will have a direct effect and indirect effect. The indirect effect of the force will be represented in the form of a moment. Make sense? How we can calculate this moment? It is a force times the normal distance. So what does it mean, a normal distance? To explain it, let us consider that you do have this object like a stick, and somehow this stick is pivoted about a point, like this point. And for some reason, this stick is subjected to this force F. So because of the force, if this stick is freely to rotate, if you apply a push over this stick, it will start to rotate. It start to rotate, it means there should be a moment. It means that this force, it will have indirect effect that gives rotation to this stick, to this bar. This bar is pivoted. It is pivoted at one end, and you are applying a force. So once you push from this side, it will start to rotate. We said that the moment, it is related to the rotation. It means that it looks like you are applying a moment over this object. So this force will have indirect effect. This indirect effect will be represented in the form of the moment. So the question is, what is the moment that is acting over this bar due to this force? So again, the question is, what is the moment that is acting over this bar due to the force? How much it is? To calculate the moment which represents the indirect effect of this force, which is needed to give rotation to this bar, this moment will equal the force times d. This d, it should be the normal distance between the point of rotation. Where is the point of rotation? About which point that this bar will rotate? It will rotate about the pivot. This is the joint or the pivot about which this bar will start to rotate. So this point O will be the point of rotation. So if you measured the distance between the force F and the point of rotation, this is the condition. We are measuring the distance from the point of rotation and the force. This is gonna give you D, but this D, which stands for distance, this distance, another condition that it should be perpendicular to the force. It should be normal. Normal, it means perpendicular to the force, making 90-degree angle with the force direction. This force is vertical, acting over the bar. So this force had the potential to give rotation, to produce a moment over this bar to rotate it. How much of this moment? It will equal to the force times the normal distance from that force to the point of rotation, according to this expression. So again, what is D? D, it should be the normal distance, because there are lots of distances that we can calculate from the force to the point A. For example, the distance from this point to this point A over the inclined direction, this is not the normal distance. This is a distance, but another distance. We are seeking the normal distance, the distance in a direction that is perpendicular to the force direction. This should be the D to calculate the moment. This is the simplest expression and way of calculating the moment, and this is what does it mean a moment. So again, it gives, in the mechanical application, it gives rotation. It represents the indirect effect of any force. So generally speaking, in any machine, in any mechanical component that is subjected into some forces, over the last video we knew how we can calculate the resultant of these forces. These forces, they do have a direct effect, but in the meanwhile, they do have indirect effects. When you study, when you do force analysis, when you do design to the mechanical component, you should consider the two effects. You should consider the direct effect, so that's why you should know how you can do force analysis, as we explained over the last video. In the meanwhile, you should consider its indirect effect. It means that you should know how you can do moment analysis. And this is what we are going to discuss over today's video. We are discussing the moment analysis. What is the moment? This is the indirect effect of that force. Make sense? So this is the objective of today's video, and this is very quick. What is a moment and what is the some of the benefits of the moment? So what we're going to do next, we are going to explain with more detail how we can calculate the moment according to this expression of the force times distance. So we're going to practice and we're going to consider some example just to show you how you can calculate the normal distance. This is the key condition, that you should know how to calculate the normal distance. Let us consider this example, this very simple example of a bar that is fixed at a point O. And it is required to calculate the moment due to this force acting at point O. So what does it mean at point O? It means that the moment will be different from one point to the other point, and this is a critical thing that you should understand. You should know exactly, it should be specified to you at which point you are required to calculate the moment. Why? Because the moment, it will be different and varying from one point to the other point. For example, if let us assume some points, let us assume that this is point O as given, and let us consider another point like point A, point B, and point C. So the question is the moment at point A, O, equals to the moment at point A or B or C? No, it is not necessary. It could equal or not, it depends. But in many of the cases, they are not equal. So again, the moment at point O, it will be different than the moment at point A, different than the moment at point B, the moment at point C. It will be different depending on the point. So that's why you should know at which point you are required to calculate the moment. This is a critical condition. This is a critical thing to know. Make sense? This is one point. Another thing is that the moment, as we explained, it is the indirect effect of the force. So we're still having the same force, which is 100 Newton, but this force will have different indirect effects. What does it mean? It means that this force will produce a moment, which is the indirect effect, at point O that is different than the moment, which is the indirect effect of the 100 at point A, or the indirect effect of the 100 at point B will be different than C, than O, than L. It means that the indirect effect of the force, which is the moment due to the force, will be different from one point to the other point. Make sense? So for example, if you are required to calculate the moment at a point, you should specify the point first. So you should know, let us calculate the moment at point O, which you should understand that it is not equal to the moment at point A, it is not equal to the moment at point B, is not equal to the moment at point C. They will be different. Why it is different? Because going to the expression of the moment it is a force times distance. We're still using the same force, which is 100. But the distance from point A to the force is different than the distance from point B to the force is different than from the distance from point C to the force. All of these distances are different. That's why the moment at A is different than B, is different than C. Different because of what? Because of the distance. Despite we're still using the same force, the distances are different. So let us assume some values of the distance. Let us assume that the distance between A and the 100 Newton, it is like 1.5 meter, and the distance from B to the force 100, it is 1 meter. Let us assume these values. In addition, the distance from point O to the 100, it is already given by 2 meter. So if you are required to calculate, let us calculate the moment about point O equals, according to the expression, it should equal to the force times the distance. How much is the force? It is 100 times. How much is the distance from point O to the 100? It is 2 meter. But there is a condition for this distance. What is this condition? This distance should be normal, perpendicular to the force. The force is vertical, so the distance should be horizontal, because the perpendicular to the any horizontal direction is any vertical direction is horizontal direction. It means that this 100, if it is vertical, if the force is vertical, the distance you have to choose a horizontal distance, a horizontal dimension. This 2 meter is known as dimension. So this dimension, it is a horizontal dimension. It is perpendicular to the force. So this 2 meter will be the distance. I'm seeking the normal, the perpendicular one to the 100. So it means that you're going to multiply 100, which is the force, times 2 meter, which is the normal. This gives in total 200. So what does it mean? It means that the indirect effect of the 100 force, which will be represented in the form of a moment, which means that the moment due to the 100 at point O will equal to 200. What should be the unit? Simply, we multiply force, which is given in terms of Newton, times the 2 meter, which is given in terms of meter. So the unit for the 2 were given by meter. The unit of the 100 was given by Newton. So the unit of the moment will be the multiplication of Newton times meter, the same way. Newton times meter, 100 times 2. So the unit for the moment will be Newton times meter. Make sense? As we mentioned, the unit, it is a big deal. There is no physical quantity that can be described without a unit. The unit is what gives sense and meaning to any number. The 200 by itself, it is nothing. It is nonsense. Unless you follow this 200 by Newton times meter, which indicates the unit for this moment. Newton times meter, it is equivalent to joules. It is equivalent to joule. The joule equals Newton times meter. This Newton times meter, it is equal to joule. And as you know from physics, the joule, it is the unit for the energy. What is the unit for the energy? It is joule. From physics, from the high school even. So what does it mean? It means that this indicates that the moment, it is a form of energy, as I explained above. So the moment, it is a special form of the energy that describes the indirect effect of any force. So doing the same, how about if we are interested in calculating the moment about point A? So about point A, you're going to calculate the force, which is 100, times the distance. How much is the normal distance from the point that you're calculating at? I'm calculating at point A. So what is the normal distance from point A to the 100? This normal distance should be perpendicular to the 100 direction. The direction of the 100 force, it is vertical. It means that you have to choose horizontal dimension, horizontal distance. This horizontal distance, it is 1.5 meter. The distance from point A to the 100. So it means that it will be 100, the force, times the distance, which is 1.5 meter. If you do the multiplication, this is going to give us 150. What should be the unit? Again, it will be Newton times meter. Why Newton times meter? Because you are multiplying a Newton times meter. Newton force times distance. Make sense? As you can see, the moment at point A is different than the moment at point O. At point O it is 200, but at point A it is 150. How about the moment at point B? Equals 100, which is the force, times the distance. How much is the distance from point B to the force 100? Directly it will be automatically, as we did with the A and O, it will be intuitively, it will be 1 meter distance, right? The normal distance, it will be 1 meter. This is gonna give you 100 Newton meter as a moment at point B. Now let us calculate the moment at point C. How much it is? The moment at point C, it should equal to the force 100 times the distance from point C to the 100 Newton. How much is the distance between point C and the force 100? It should be 0. Why 0? Because the force, it intersects with the point. It goes over the point. It passes through the point. It means that there is no moment, there is no distance. Why there is no moment? There is no distance. There is no normal distance between the force F, which is 100, and the point C. There is no normal distance between them. What is the reason? The reason is that the force goes over, passes through the point C. If there is the case, it means that the distance, it will be 0 automatically, and this directly will give you a 0 moment. Will give you the moment equals 0. So what does it mean? It means that at point C, the force, it has only one effect. It has a direct effect. Has no indirect effect. There is no indirect effect at point C due to the 100 force. But the 100 at point B, the 100 is directly acting at point C. It is over point C. So it has a direct effect at point C. But has no indirect effect, has no moment. So that's why the moment at point C is 0. But the question is, does the 100 Newton acting directly over point B or A or O? No. The 100, it is not coincident, or is not intersecting or going over, or is not directly acting over A or B or O. So what does it mean? It means that the 100 has no direct effect over these forces, but it will have indirect effect in the form of moments. So that's why there is a moment about point O that is different than the moment about point A, that is different than the moment about point B, and so on. So according to this moment at C, generally speaking, the moment due to the force at any point that is coincident, that is over the force, that is intersecting with the force, has 0 moment. The moment will be 0 in case that the force is intersecting with the point. The moment at that point will be 0. Why? Because the force is intersecting with that point directly. It means that there is no normal distance between them. So there is a condition to have a moment, that there should be a normal distance. Make sense? So this is simply very quick for this simple example how we can calculate the moment and how it would be different depending on the point. So that's why you should know at which point you are going to calculate the moment. Make sense? Now let us move to this other example. Another example here. Let us calculate the moment about point O, the moment about point O, how much it is. So how many forces do I have here? We have only one force, which is 50 Newton, but this force is horizontal force. And this is the point O. And we are interested in calculating the moment due to that force, the indirect effect of this force about point O. So the question is, what is the equation or the formula for the moment? The moment, it should equal to the force times the distance. But which distance? The normal distance. How much is the force? It is 50, so there is no big deal for the force, times the challenge here. How much is the distance? How many distances or dimensions are drawn over this graph? We do have 2 dimensions. One is a horizontal dimension, which is 2 meters. The second one is 0.75 meter, which is a vertical dimension. Which one of these two dimensions that should be counted as the distance d, that it should be normal to the force 50 Newton? You should choose the 0.75 meter. Why? Because you are seeking the normal to the force. The force, it is horizontal, so you have to choose a vertical dimension, not a horizontal dimension. It means that the 50 times 200 has zero moment at point O. There is no moment due to the 50 multiplied by 2. The 50 multiplied by the 0.75 meter, it has a moment about point O. It means that you have to choose the normal distance. This is the condition. Here we do have two distances, one horizontal, one vertical. Which one that you have to choose? The vertical one. Why the vertical? Because the force is horizontal. You should choose the direction that is perpendicular to the direction of the force. The force horizontal, you have to choose the vertical dimension, which is 0.75 meter. So if you did the multiplication, 50 times 0.75, this gives the 37.5, 37.5. What should be the unit? Newton times meter. Why Newton times meter? Because the force here is in Newton. The dimension 0.75 was given in meter. This is gonna give you the Newton times meter. Make sense? How about this example? We do have this bar, and we are interested in calculating the moment about point O as usual. So the expression, it should be the force times the distance equals. How much is the force? It is 7 kilonewton. I don't care about the sign. What does it mean? No matter the sign is, you're just gonna carry on the unit. It doesn't matter what is the unit it is. You're just gonna carry on the unit when you define the unit for the moment, as I'm gonna show you. But anyway, it is 7. This is the value of the force. It is 7 kilonewton. And the force here is horizontal, so it should be multiplied times the distance. But here we do have three distances, not just one. And remember that we are calculating about point O. So if I ask you, this is a little bit tricky. If I ask you what is the normal distance between the force and the point O. If you're already standing here, just to make it easy for you, assume that you're already standing here and you are trying to go from this point to point O. So you're gonna do two displacements. You're gonna move in two directions. You're gonna move horizontal, then vertical, or vertical, then horizontal. It doesn't matter which one first, which one second. So again, if you're standing here, assume that, and I'm asking you to go to point O, what you're gonna do? First of all, you're gonna, for example, go to horizontal. You're gonna move 2 meters horizontal. So there is 2 meters horizontal distance. How did I know that it is 2 meters? Because simply it is the same distance, right? This dimension here, it is 2 meters. It means that you're gonna move 2 meters. Then you're gonna drop down, move down, vertical. Keep going down. How long? What is the vertical distance that you're gonna move till you reach to point O? Is it 4 meters? No. You're gonna move the difference between the 4 meters, because the 4 meters, it is measured from the top till down here. So this entire height, it is 4 meters, and this small height, it is 1 meter. It means that you're gonna move the difference because you're starting from here. So you're gonna move just 3 meters, not the entire 4 meters. So this gives you two dimensions, two distances. One horizontal, the other one is vertical. The horizontal, it is 2 meters, the vertical, it is 3 meters. This is one way. There is another way around, like you could move this way. And instead of going horizontal first, then vertical, how about if I decided to move vertical first? Then once I be at the same level as point O, I'm gonna move to the left. So the vertical distance still will be 3 meters, because at the end you're gonna end up with a rectangular shape. And this horizontal distance also will be 2 meters. So now for the point at which the force is acting, there are two distances. One is a horizontal distance, so I'm just gonna give it a name as HD, horizontal distance equal 2 meters. And we do have a vertical distance, VD, vertical distance equal 3 meters. So when you're gonna calculate the moment due to this force acting at point O, which of these two distances that you have to choose, that you have to substitute here for D? We are seeking the normal distance. This normal distance should be perpendicular to the direction of the force. The force, 7 kilonewton, it is horizontal here. It is here horizontal. So it means that you have to choose the vertical distance, not the horizontal distance, the opposite one. If the force is horizontal, you're going to choose the vertical distance. If the force is vertical, you're going to choose the horizontal distance. Very simple. So this is a very simple approach how you can specify the normal distance. That start from the force that acting at the force, the point at the force. Then try to move to the other point, move to point O. Horizontal and vertical, or vertical then horizontal, it doesn't matter which is the order. Specify the horizontal and vertical distances, then you're gonna choose one of them that is perpendicular according to the direction of the force. If the force is horizontal, choose the vertical distance. If the force is vertical, choose the horizontal distance. Here, it is horizontal, so I'm gonna choose the vertical distance, which is 3 meters. So the question is, why 3 meters? Because the force is horizontal. Doing the multiplication, this gives you 21. What should be the unit? You are multiplying this force, which is in kilonewton. The force was given in kilonewton times. The 3 was given in meter. This is the unit. So it means that the unit for this 21 will be kilonewton times meter. Make sense? So this is how we can calculate the moment for this case. Make sense so far? So simply, your objective is just to correctly allocate and define the normal force distance to the force, so you could be able to calculate the moment, how much it is. Now let us consider this a little bit more tricky example. We do have a force which is 40 pound. So the unit of the force, it is a change. There is 40 pound, it doesn't matter. And we are given here an angle of 30 degrees, and this distance, it is 20 feet. This is the unit. And this distance is 4 feet. So it is 4 feet. You're gonna deal with it like 4 meters and 2 meters, for example. So the feet is just the unit, the pound, it is just another unit. So this is 40 pound. It is required to calculate the moment about point O. So again, it should be the force times the distance. How much is the force? We have only one force, which is 40 pound times. Now how we can calculate the distance? We are seeking a distance, right? Which distance? We are seeking the horizontal distance to the point O. If I ask you, if you're already standing here, and I ask you to move to point O, how you gonna move? So first, you're gonna move down this vertical distance, right? Then you're gonna move horizontal all the way till you reach to point O. So this gives you two distances. One is vertical, one is horizontal. Make sense? So we're gonna have here vertical distance and horizontal distance. Let us calculate the horizontal distance. How much it is? This horizontal distance should equal to the distance from this point to this point. It is given by 4 feet. This dimension, it is confined between these two lines. These two lines, it means that this distance from this point to this point is just 4 feet. But the HD, it should be this entire distance, this whole length, it should equal to the HD. It means that the HD, this horizontal distance, it should equal to the 4 feet plus something. This part, how much it is? This dimension, how much it is? We need to calculate it. To calculate it, you're gonna choose this triangle. Do you see this triangle? If let us draw this triangle on the side here, just to explain it to you. So we do have this hypotenuse is given by 2 feet. And this should be vertical line, and there should be another horizontal line, and this angle is gonna be the 90 degree. I'm representing this triangle. And the angle, this angle was given by 30 degrees. So from the trigonometry of this triangle, or this specification of the upright triangle, What should be this horizontal distance and vertical distance? So the horizontal distance, this side, it is the adjacent to the angle. So directly it will be the hypotenuse, which is 2, times the cosine of the angle 30 degree, which is very similar to the thing that we explained over the last video. We said that any adjacent force is going to take the cosine, the other one is going to take the sine. The same thing, it is applied here. So simply this 2, which is the hypotenuse, this side it will be the adjacent to the 30 degrees, so it will be the cosine of 30 degrees. How about this side? This is the opposite to the 30 degrees. So we knew even from the high school that this opposite side, it will be the hypotenuse length times the sine of the 30 degree. So all the time the side of the triangle that is opposite to the angle takes the sine, the side of the triangle that is adjacent to the angle takes the cosine. So that's why we have 2 cosine 30 and 2 sine 30 for the vertical and horizontal dimensions. It means that this small distance here, this distance here, it is already 2 cosine 30 degrees as already written down there. So if I ask you how much is the entire HD horizontal distance, it will be the 4 foot or the 4 feet plus the 2 cosine 30 degrees. If you're gonna calculate this, this is gonna give us the 2 times the cosine of 30 degrees plus 4. This gives us the 5.73 feet. The unit, it is a dimension. It means that this entire distance will be this value feet. How about the vertical distance? The vertical distance will be this vertical line, right? This vertical line we calculated from the triangle by 2 sine 30 degrees, right? So this it will be 2 sine 30 degrees. Doing the calculation, this is gonna give you 1 feet or 1 foot. Make sense? So we calculated the horizontal distance and the vertical distance. The question is, which one of these two distances, the 5.73 or the 1 foot, should be substituted here to be multiplied times the 40 to end up with the moment at point O? Which one? You should choose the one that is perpendicular to the direction of the force. The force was given vertical. The force was given vertical as already given here. So it means that you have to choose the horizontal distance. The horizontal distance, it is 5.73 foot. Do the multiplication. This is going to give us 4 times 40. This is going to give us 22, 9.28. What should be the unit? It should be bound, because the force here is in bound, times the dimension, which is foot. So it is going to be bound foot. This is the unit for the moment, which is a force this is the bound foot. This is the unit for the energy in the American system, unit system. Make sense? How about this example, which is also have the same challenge? We'd have something inclined in this way. So we are interested in calculating the moment about point O. So again, it will be the force times the distance. How much is the force? It is 60. The force, it is 60. Times, now let us calculate the distance. How we can calculate this distance? Assume that you're already standing here. Then, if I ask you to move to the point O, because we're calculating about point O, so you're gonna move this horizontal distance, right? Then you're gonna jump up. Be smart, so you aren't gonna waste time to calculate both distances. So we have horizontal distance and vertical distance. Which one of these two distances that you need? We need the vertical distance. Why the vertical distance? Because the force was given horizontal, so I should calculate the vertical distance. I should substitute here for the vertical distance. But how much is this vertical distance? We need to calculate it. This vertical distance, this vertical line is equivalent to this vertical line in this triangle. So we're gonna form this triangle here, this one. If we decided to draw this triangle, on the side, it will be represented in this way. Like you're going to have a vertical line, which this vertical distance, this is the vertical distance that we are seeking. And there should be another horizontal line with this slight horizontal line. And this is the hypotenuse. This length, hypotenuse, was given by 1 feet or 1 foot. So it is 1 foot. This is 1. And this angle is given by 45 degrees. This angle, this entire angle is given by 45 degrees. So what should be the vertical distance? The vertical distance is going to be the hypotenuse, which is 1, times either the cosine or the sine, depending on what, depending if this vertical distance, is it opposite or adjacent to the 45 degree? It is opposite to the 45 degree. It means that the vertical distance will equal to the hypotenuse, which is 1, sine. It should use the sine of the 45 degrees. It means that here I'm going to substitute for 1 times the sine 45 degree to calculate the vertical distance. So this is the vertical distance. Then your objective is just to do the calculations. This is going to give you the 60 times the cosine of 40, the sine. Anyway, the cosine and the sine, they are the same for the 45 degree, but to be more specific, it should be the sine. So this is going to give us 42.426. What should be the unit? The unit of the force, it is in pound, times the unit of the dimensions, or the dimensions were given in foot. So it should be pound foot. This is the unit for the moment. It means that the moment at point O, due to this force, it is 42.426 pound foot. Make sense? So this is for the calculation of the moment, how we can calculate it. The critical condition is how you specify the normal distance from the force to the point that you're calculating the moment at. And another thing that you should understand, that the moment it will be varying from one point to the other point. Make sense? Alright, so how about if you do have this object is subjected to more than one force? Or the example that we explained above, we were having only one force and we were calculating the moment due to this single force. But how about if this bar, for example, it is subjected to more than one force? It is not just one force, more than one. How much is the total moment will be then? It means that every single force will have a moment about point O. So if we calculated the moment due to every single force at the point O, can we sum all of them to end up with the moment resultant? Yes. Since we are working in the same plane, there are lots of specification and other more complicated cases that we can calculate the resultant moment at, but here we're just considering the simplest approach or the simplest way or the simplest case, that we are interested in calculating the resultant moment at a specific point due to a set of forces, all of them acting in the same plane. This is the condition, or this is the case, the simplest case that we are going to consider in this part. But if the forces, just to let you know, just for your information, if the forces are acting at different planes, the calculation of the resultant moment will be a little bit different. It will need more steps than the one that presented here. But this is what we are going to consider here, that we are interested in calculating the resultant moment due to a set of forces, all of them acting over the same plane, over the same object. Okay, so the procedure, I'm just going to read the procedure and it's going to be much more clear when we're going to consider the next example. So the procedure is very similar to the things that we did before for the resultant force analysis over the last video. The first step, typically the same, decompose each inclined force into two components parallel to X and Y. As we did the last video, any force that is inclined, your objective is just to decompose this force into horizontal and vertical direction. This is the first step, nothing new in comparison to the previous video. Then the second step, you're going to calculate the moments due to all the forces along X direction. Any force along X direction, you're going to calculate the moment due to every individual force along X direction. Then you're going to repeat again. Then you can sum all of these moments together, so you're going to end up with the resultant moment along the X direction, for example. Then you're going to repeat again and calculate all the moments due to every force along the Y direction. And then you're going to sum all of them together. So you're going to end up with total moment along X and total moment along Y. Then you're going to sum them together, this total moment that you calculated in step 3 and the total along X and the total moment along Y that you calculated in step 5. Then you're going to sum all of them together. You're going to end up with the moment resultant. There is no square root of moment square plus the other moment square as we did with the resultant force calculation over the last video. No. Here we are working over the same plane. It means that you just gonna sum all the moment. There is no square roots, there is nothing. As we did for the force resultant over the last meeting. Make sense? So to explain these steps with more detail, let us consider this example here. We do have this elbow or this structure, whatever it is, and it is subjected into two forces. Both are inclined in this way. This force is given by 600 Newton. This is 500 Newton. This force is inclined with an angle 60. So as we explained over the last video, any force that is inclined, it should be combined with an angle. It should have an angle. So this angle 60, it belongs to the force F2. But how about the force 500 F1? It has no angle. There is no angle specified. But instead, he gave us this triangle. We already solved an example in the last video. In case that you have a triangle, what you should do. So here we are not interested in the force resultant, but we are interested in the moment resultant. It is required to calculate the moment resultant about point O. This is one of the examples in the exercise sheet that I provided. So how we can solve them? Let us consider this example 1. What is required? Calculate the moment resultant at point. He should specify a point for us. We said that the moment at any point will be different from the other point. So you should know exactly at which point you should move, calculate the moment. For example, if I give you the question in this way, calculate the moment resultant, and I didn't specify a point, you don't do calculation to anything. Why? The question is wrong. I should specify a moment for you. Okay? At this level of knowledge. But anyway, in the mechanical design course, you should be the one who specify at which point that you calculate. But at this level, you have no clue how you can specify the point. So that's why I will give you the point at which you will be required to calculate the moment like point O. Make sense? So how we calculate it? Let us apply the procedure. The first step in this procedure, we have to decompose all the forces into inclined forces into horizontal and vertical forces. How many forces inclined? Would have 2. Let us start with the simplest of them, which is the force 2. F2, it is inclined in this way. So to decompose this force, you're gonna confine it between two components, one vertical in this way, one horizontal, to confine the force as we explained over the last video. Then these two components should behave the same way like this force. This force is projected from this point A. It means that these two components as well should be projected doing the same as this force, F2. So that's why we specify the direction of this force, right? And this force will be going down vertical. Make sense? Then what should be this component? One of these two components is going to take the cosine, the other one is going to take the sine. Which takes the cosine, which takes the sine? The cosine goes to the one that is adjacent to the angle, that confines the angle with the resultant force, with the force F2. This angle 60 is confined between F2 and this horizontal component. So that's why this horizontal component is going to take the cosine, while the vertical component is going to take the sine of the angle. The angle is 60, so this is going to give you 600, which is the force magnitude, the cosine of the 60 degrees. Make sense? How about this one? It will be also 600, but the sine of the 60 degrees. Then we can cancel this force. So this is the first step. Just to decompose an inclined force, we decompose the first force. We still have one more force to go. So the second force also, it will be decomposed into two components. One component will be horizontal in this way. The second one will be vertical in this way. Both are confining the force in between. And this one, it should go to the right, doing the same way, projected from the point at the F1. And this one, which should be also projected from the point as F1. So both will be projected. What would be the component here? There is no angle. We said that since there is no angle, we're going to use the triangle that is provided. He provided us this hypotenuse 5. This side there is 3, 4, this side there is 3. So this horizontal force, is it better, or the two forces, we said that the force, it will be the 500, which is the magnitude of the force, times a fraction. The denominator of the fraction will be the hypotenuse of the triangle. The hypotenuse of this triangle is given by 5. So there should be, in the denominator of this fraction, there should be 5 here. The same thing here, we should have 500, which is the magnitude of the force. Then you're gonna have a fraction. This fraction, the denominator, it will be 5, which is the hypotenuse of the triangle. We still need to specify the numbers, these two numbers on the top, in the numerators. On the top here, this horizontal force, is it parallel to the 4 or the 3? It is parallel to the 4. It is horizontal like the 4, which is horizontal. It means that you're going to use horizontal here. The horizontal distance or dimension here, which is 4. The same thing, this one is vertical, which is parallel to the 3, which is vertical. It means that you're going to use the 3 here. So this gives us the two components of the F1, the horizontal and vertical component. Now we can cancel this one. And that's it for step 1. Step 1 is just to decompose all the forces into two components, horizontal and vertical, in this way. Then what? Step 2, your objective is just to calculate the moment due to all of these forces. You can start with the horizontal forces first, then the vertical forces, or you can start with the vertical, then the horizontal. It's up to you. How many horizontal force do we have here? We do have two forces horizontal. 600 cosine 60, this is one force. The second force is 504 divided by 5. So let us calculate the moment due to these two horizontal forces. So we're going to calculate the moment along X, the horizontal direction first. Take it step by step, one by one. So the moment due to any force, we mentioned that it equals the force times the normal distance. So here we are lucky in this problem. Why? Because in this problem, all the forces acting at point A, all the forces acting at one point. So it means that with these horizontal forces, you require a vertical distance, but with the vertical forces, you require horizontal distances, right? As we said, you should seek the normal to the direction of the force, the perpendicular to the direction of the force. When you calculate the moment for these horizontal forces, you need a vertical distance, but for these vertical forces, when you calculate the moment due to this vertical force, you need a horizontal distance. So that's why let us calculate the vertical and the horizontal distances first. So if you're standing here, all the forces acting at the same point, if you're standing here, and I ask you to move to point O. So you're gonna move horizontal all the way till the end, right? Then you're gonna drop down vertical. In this way. How much it should be the horizontal distance? How long? So the horizontal distance, so I'm just gonna name this one HD, stands for horizontal distance, and this one will be VD, stands for vertical distance. So if I ask you how much is the horizontal distance? The horizontal distance will be the sum of the 0.3 meter plus the 0.125 meter. So it will be 0.3 plus the 0.125, which gives you 0.425 meter. So this is the horizontal distance. Agree? How about the vertical distance? How much it is? It is already given by 0.25 meter. 0.25 meter. So we calculated the vertical distances and the vertical distance and horizontal distance. We're gonna need them, both of them. So when we calculate the moment along X direction, due to the horizontal forces, we do have two forces. So both forces will be multiplied times the vertical distances. Why? Because we are calculating the moment due to these two horizontal forces. So I have to choose their perpendicular direction, VD, vertical distance. So this force, the first force, it is 600 cosine 60 degree. This is the force times the distance. Which distance? The vertical distance. Why vertical? It is horizontal force. So it should be 0.25 meter. 0.25. Make sense? So this is one moment due to the first force. How about the second force? it is 500 times 4 over 5. This is the force itself. I didn't specify any signs yet. Times which distance? The vertical distance as well. Why this force? It is horizontal force, so it will be 0.25. This gives you the second moment. So this is one moment, this is a second moment due to the two forces. Now we need to sum them together to end up with the total moment along x direction, or due to these horizontal forces. Make sense? Due to the forces, the horizontal forces only. So which one it should be positive, which one it should be negative? It depends. You can assume any direction is positive, the other direction will be negative. The key condition is that you should assume, for example, if this is the direction of the force, and this is also another tricky part, how you specify the direction of the moment, the sign of the moment. So if I ask you, this is the point and this is the force, this force will be projected out. And if I ask you to go to point O, assume that you already riding a rocket, and this rocket will be projected, will be launched in this direction, horizontal. And for some reason it should return to point O. So it's going to return going up or going down. It will be easy for it, it will go down. It means that you're gonna move this way, then you're gonna go down to the point O. You got my point? The force is projected in this direction, so you will go in this direction, then you're gonna turn to return to the point O one more time. Make sense? So this is gonna give you the direction. It means that the direction of the moment due to the 600 cosine 60, it goes in this direction. This direction, is it clockwise direction or counterclockwise direction? This is clockwise direction. This is the clockwise direction. You can assume, for example, the clockwise direction is negative, so the counterclockwise direction will be positive. It's up to you. Assume any direction positive, the other one will be negative. So again, to specify why I'm explaining these things, because you need to specify the sign. To sum, we said that the summation, it doesn't mean that all of them should be added. Some of the moments could be positive, some of them will be negative. Which one of these two moments will be positive, which one will be negative? This depends, it needs investigation on the directions. The directions would have two directions for the moment. Either clockwise direction or counterclockwise direction. Why? Because the moment it will have a rotational effect, like you rotating. So our reference is point O. Why point O? Because we are seeking the moment at point O. So we have to specify the direction of these moments with respect to point O. How we can do so? Your objective is just to ask yourself, you standing here, assume this, you're standing here, and this is the direction of the force. Assume that you're riding a rocket, and this rocket will be launched in this direction. So you're gonna go to this direction, then you're gonna return to point O one more time. Make sense? Someone would say, why I dropped down, I didn't go up. So for example, you can go to point O the other way, right? The other way around. But it doesn't work in this way. You should consider the direction of the vertical force, the vertical distance. For example, that you're already here, so you're gonna move from this point going down. So this line is over the start of this point, over the same horizontal line, and this point will go down, will be dropped down depending on the vertical distance. Because this vertical distance, you're gonna go down because this point is here, or simply, it is very simple thing. When I ask you to move from point A to point O, you move horizontal, then you move down. So that's why you should go down. Because point O is below the point A. So you should go to in the same direction, the closest way, the shortest way to the point O. So that's why this A, you assume that you're riding a rocket, will be launched in this direction, then it will be returned back again to point O. Make sense? Because our reference, we need to reset back to point O, so we're gonna move down. So this is gonna give you a direction. This direction, it is clockwise direction. And let us assume that the clockwise direction is negative. So this means that if the moment goes in the counterclockwise direction, it will be positive. It's up to you. You can assume any direction is positive, the other one will be negative. Any one positive, the other one will be direction. It's up to you which direction is positive. Make sense? So let us assume that the clockwise is negative, the counterclockwise is positive. So according to this, what should be the sign of this moment? The 600. The 600 will be going down because it will be launched in this direction, return. So it is clockwise direction. So it should be negative according to my assumption here. It means that this will be, this is going to give you the moment mx will equal to negative. How about the 504 over 5? Also it will be projected in the same direction. It will be launched in the same direction clockwise. So it will be negative according to my assumption. Then you can sum these two moments together. So you're going to end up with negative something. If you did the calculation, this is going to give you 600 cosine the 60 degree times 0.25. And the other force will be the 500 times 4 divided by 5 times the 0.25. So this gives negative 75. And the second one will be negative 100. The sum of both will be negative 175. What should be the unit? The unit of the force, it is Newton. It is 600 Newton, 500 Newton, so it is Newton. And all the dimensions are in meter, so it will be Newton meter. This is the unit for the moment due to the horizontal forces only. How about the vertical forces? Let us calculate the moment due to the vertical forces in the y, in the vertical direction. We have two forces. One is going up, one is going down. So how we can deal with these two forces in terms of moment? So let us calculate the moment. So the moment due to the 503 over 5. So the force will be 500 times 3 over 5. This is the force. Times the distance. Which distance? This force is vertical, so you have to choose the horizontal distance. The horizontal distance that we calculated is 0.425. So it is 0.425. Make sense? This is the horizontal distance that we calculate, which is this distance. So this is the moment due to the first force. How about the moment due to the second force? The second force, it is 600 sine 60 degrees. This is the force itself. This is just the force times the distance. Don't forget the distance. The distance, it is still the horizontal distance. Why? Because the force is vertical. I don't care whatever it goes up or down, but anyway it is vertical. So you have to multiply times the horizontal distance, which is 0.425. So this gives you the second moment. How about the sign of these two moments? Which one is positive, which one is negative? Depends on what? Depends on the direction. Depends on this assumption. This assumption, you're going to stick to it till the end. You're going to assume any direction is positive. The other one will be negative. And you're going to stick to this assumption till you finish the entire problem. This is important thing. So, let us see the direction of this 500 force. This force, to go to point O, assume that you're already standing at point A. Why point A? Because the force is projected from point A. And assume that you're riding a rocket. So the rocket will be launched vertical, right, with the force, going in the same direction of the force. Then it will be dropped down again to return to point O. Why we are returning to point O? This is our reference. We are calculating the moment about point O, so we have to return to it. Assume that you're riding a rocket and this rocket will be launched vertical, then it will return back again to point O. So this gives you the direction. What is this direction? This direction, it is counterclockwise direction. It is anti-clockwise direction. And according to your assumption, we assume that the counterclockwise, it is positive. So this means that this force, it should be positive force. Or this moment, it should be positive, not the force. The moment will be positive. So this moment is positive. This is not related that the direction of the force is vertical, so that's why it is positive. No. It depends on the direction of the moment. Is it clockwise or counterclockwise? And it depends on your assumption. So you have to investigate the direction. Let us do the same for the other force. This other force, which is the 600 sine. If you're already standing here and you're gonna ride a rocket, and this rocket will be launched down, going down. Why down? Because the force goes down. And then you should reset back to point O. So you're gonna go all the way. This is the shortest way. This is the shortcut. So you're gonna go directly to point O. It means that this is gonna be the direction of the moment. This direction of the moment, it is clockwise direction. And according to the assumption, the clockwise takes a negative sign. It means that this force, 600 sine 60 times 0.425, this moment will be negative. Why negative? Because it is clockwise direction according to these investigations. Make sense? So now we're gonna calculate this summation. We got this positive, this one is negative. Do the calculation to this term and then this term and calculate the entire my. So this gives us equals 500 times 3 divided by 5 times the 0.425 gives 172.5, 27.5, and it is positive. Remember, negative, the 600 sine 60 times the 0.425, this gives 220.84. Make sense? Then if you just do the calculations, this is gonna give us the negative of negative 93.336. This one is negative and that one is negative. That is fine. This value could be positive. This value could be positive. It depends. And then your objective is just to specify the unit. Definitely the unit, it will be Newton times meter, the same unit as the mx that we calculated up there. So now we got the moment. mx, this is the moment due to all the horizontal forces, all the forces that parallel to x. And my, this is the moment due to all the vertical forces which are parallel to y, which 503/5 and 600 sine 60. Make sense? Now, what should be the total moment? The total moment is just to sum these two numbers. So the moment resultant, or the resultant moment, mr, equals mx that you calculated plus the my, just the summation of these two terms. So mx, we got it by negative. We got it by negative 175. And the my, we got it by negative 93.336. So negative 93.336. Your objective is just to sum these two numbers together. This is gonna give you the value which will be negative 268.336. What should be the unit? Newton times meter. So this gives you the resultant moment. Due to these two forces, all of these forces, we calculated the moment of each one, then we summed all of this moment together that gave us this resultant moment. This is the indirect effect of these forces about point O. So this is the resultant moment at point O. Should be calculated at this vertical bar, indicate that this will be calculated at a point. This point, it is point O. Make sense? What does this negative means? This negative indicate that the moment due to these forces will be directed clockwise. Why clockwise? Because you assume from the beginning, assume that this moment, any moment that goes in the clockwise direction will be negative. We got the sum of the moment result that we got it negative. It means that the moment due to these forces will be in the clockwise direction. But if we get it positive, it will be in the counterclockwise direction depending on your assumption, because we assume that. We assume these directions, the clockwise will be negative, the counterclockwise will be positive. So this is the procedure. This is how we can calculate the moment due to a set of forces acting over a structure, over a mechanical component. But the condition is that all of these forces acting over the same plane. And this is the thing that we are going to consider for this part. Make sense? So that's it for today. This is what we explained. Today we explained what does it mean a moment in general. Also we discussed some of the benefits of the moment, and we said that this moment has this is the indirect effect of the force. Then we investigated how we can specify the normal distance to the force to calculate the moment at a specific point. Then we consider this example to calculate the moment resultant at a point due to a set of forces acting over this structure or this mechanical component. Make sense? So that's it for today's video, and thank you, and see you in the next meeting.